Okay, so this is 2018 AMC 10B problem 11. Which of the following expressions is never a prime number when p is a prime number? So we have p squared plus 16, p squared plus 24, p squared plus 26, p squared plus 46, and p squared plus 96. Okay, so it doesn't look like we have any, good method of solving this problem, so using proper math. So let's just try and eliminate our answer choices to get the right answer. So for the prime numbers, I reckon you memorize prime numbers under 100 because that's really important. So, and it will save you a lot of time in these type of problems. So let's start with p equals 2. So the possible values, 2. Okay, so when p is 2, we have a is going to be 2 squared plus 16, which is going to give us 20. So that's not a prime number, so you can't cross that out. So b is going to be 2 squared, which is 4 plus 24, which is 28. And all the other terms here, c, d, e, are not going to be prime numbers because 2 squared, so p squared, is going to be equal to 4. So when p squared is equal to 4, and if we add an even number to an even numbers, then we get an even number. So if these numbers are divisible by 2, they can't be prime. So we can't have p equals 2 to eliminate any answer. So let's try p equals 3. So when p equals 3, a is 9 plus 16, which is 25. B is 9 plus 24, which is 33. C is 9 plus 26, which is 35. D is 9 plus 46, which is 55, and E is 9 plus 96, which is 105. Okay, so let's try the next number. That is prime. So P is 5, which means that P squared is 25. The 25 plus 16 gives us 41. So 25 plus 16 is 41, so we can eliminate A. So let's just write that down. Alright, so we have A eliminated. So we have 25 plus 24, which is 49. 25 plus 26, which is 51. 25 plus 46 is equal to 61. So we can eliminate D. So let's just write that down. So 25 plus 46, wait, that's equal to 71, my bad. Okay, that's equal to 71. But 71 is also prime. Okay, so we can eliminate A and D now. So 25 plus 96, so 25 plus 96 is going to give us 121, which doesn't eliminate anything. So we can try the next prime number, which is 7. So we have 7 squared, which is 49. So we have 49 plus 24. We don't have to try A because it's already eliminated. So 49 plus 24 gives us 73, so we can eliminate B. So let's just write that down. So 49 plus 24 is equal to 73. Alright, so 49 plus 26 is gonna give us, so 49 plus 26 is gonna give us 75. 49 plus 96 is gonna give us, well, some number that ends with a 5, so that's not prime because it's divisible by 5. Let's try the next prime number, so that's 11. So p squared is going to be 121. So 121 plus 26 is going to give us 147. Alright, so when c is 147, it's divisible by 3. So 147, right? For something to be divisible by 3, you want to see if its digits sum up to 3. Sum up to a multiple of 3. So 1 plus 4 plus 7 gives us 12, and 12 is a multiple of 3, so 147 is not prime. Alright, so let's see what happens when 121 is added to 96. So 121 plus 96 is going to give us 1 plus 6 is 7, 2 plus 9 is 11, and we have 217. So we firstly note that this number isn't divisible by 3. So let's just try if it's divisible by 5. It's not divisible by 2. Let's see if it's divisible by 7. So if you divide this by 7, you have So 217 divided by 7 gives you 31. Okay, so it's divisible by 7. So this number is not prime either. So we move on to the next prime number, which is after 11, which is 13. Okay, so for 13 squared, you have 169. So for 169, if I just add 26 to that, this gives me 9 plus 6 is 15. So, okay, so this number ends with 5. So it's divisible by 5, so this is not a prime number. What if we have 169 plus 96? Well, this number also ends in a 5, so that's not divisible. That's not a prime number. So let's try the next prime, which is 17. So 17 squared is going to be 289. Yeah, 289. So basically here, if we have 289 plus 26, this will give you, so 9 plus 6, which is, so this ends in 5, so that's divisible by 5, so it's not prime. If we have 289 plus 96, it's also divisible by 5, so it's not prime. So we try 17, right? After 17 is 19. 19 squared is 361. So 361 plus 26 gives you, or gives me 387. So is that prime? Not exactly, because its digits sum up to 18, and 18 is a multiple of 3, so 387 is a multiple of 3. Okay, so option C, when P is 19, isn't prime. Okay, so what about 361 plus 96? This gives me 1 plus 6 is 7, 6 plus 9 is 15. That gives me 457. So 457 isn't divisible by 2, 3, 5. So let's see if it's divisible by 7. So, okay, so 457 divided by 7 is equal to, so 7 times 6, which is 42. 37 divided by 7 gives me 5, but I have a remainder of 2, so it's not divisible by 7. So we have, let's try 11. So if we divide 457 by 11, we have 4 times 11, which is 44, and then you have 17 divided by 11, which is 1, remainder 6. So it's not divisible by 11. So we start to suspect that, this is a prime number. So, okay, let's try 13. So 457 divided by 13 is actually equal to 45 divided by 13, which 3 times 13 is 39. 45 minus 39 is 6. 67 divided by 13. So 67 divided by 13 gives me 5, remainder 2, because 5 times 13 gives me 65. Okay, so it's not divisible by 13 either. So let's try, 457 divided by 17. So let's just hope this works. So if we have, 2 times 17, which is 34. 45 minus 34 is 11. 117 divided by 17, well, 117 divided by 17 gives me, so 17 times 5 around, so that's just, so there is a remainder, so it's not divisible by 17. So let's just try if it's divisible by 19. Since 361 is divisible by 19, we only have to see if 96 is divisible by 19. So 96 divided by 19 is equal to, well, so 5, remainder 1. So it's not divisible by 19. So if we try any other prime number, like we can try 23, and you can also try 29 if you want to, but okay, they're just not divisible. So 457 is just prime. So, okay, so 457 is just prime, so we've eliminated option E. So we've eliminated 4 out of 5 options, so our answer is just going to be C. Okay, so the key here is just to, know your prime numbers and also your perfect squares. And also knowing how to figure out whether 457 is prime or not. Okay, so bye.